Okay, so just as a quick reminder of what we talked about yesterday, we talked about the circumcenter and we talked about the incenter. Can somebody remind me what the circumcenter is? So for instance, if I have a triangle, and I'll make it a right triangle just to make this a little bit easier, but if I have a triangle like this, what's the circumcenter? You guys all just found it in the rewind. So where would it be? If you can't tell me what it is, where would it be? In the middle of what? The hypotenuse? Okay, so it's the middle of the hypotenuse because it's the place where all of the whats meet. All of the perpendicular bisectors, okay? So where all All right, so it's where all the perpendicular bisectors meet. All right, what about the incenter? So we talked about that afterwards. We talked about the incenter. We said the incenter is where all of the what meet? The angle bisectors. What's the difference between a perpendicular bisector and an angle bisector? The angle bisectors, it meets in the middle. The incenter is always inside the triangle, good, and it's angle bisectors do what? They cut the angles in half, whereas the perpendicular bisectors cut what in half? The sides, okay? So I would take my angle bisector of here, this one, and then this would be my incenter. All right, so the incenter is where all the angle bisectors meet. Okay, so we're going to go through two more of these types of vocab words today. At the end, what I want you guys to know, what I told you guys was important before, what I'm highlighting is when you're doing a circumcenter, so this right here, being able to find the circumcenter on a right triangle, you will need to know, all right? And you will need to be able to tell me that the circumcenter is where the perpendicular bisectors meet, that the incenter is where the angle bisectors meet, okay? So you're going to need to know that vocab and what it goes with, but you're not necessarily going to need to know how to find a perpendicular bisector of like an equilateral triangle, all right? So just worry about those right triangles that we did yesterday. Can someone remind me what the shortcut way of finding that circumcenter is? Because you guys all did it. I didn't see many people do a lot of work for that. You guys all just got the answer. So how do you do that? Divide what by 2, Tiara? Your x and y coordinates, right? Divide them by 2. And that's if it's a right triangle and if this point right here is where? At the origin. If it's not at the origin, does that work? No. Okay, you still would just find the midpoint, but it would not be as easy as just dividing by 2. All right. Okay, so today we're going to talk about medians and centroids of a triangle. So the median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So this right here, D, is a midpoint. How do you know that? The two sides are congruent. We know that AD is congruent to DB, and you know that because of what? That little red dash, right? The little red dash tells you that they're congruent. So this line goes from the midpoint of one side to the opposite vertex, which is C. So this line right here, this line that I'm highlighting in green now, is called the median of a triangle. How many medians does a triangle have? 3. Why 3? Because there's 3 sides and 3 vertices, right? So then where would another median be? Where would another median be? From the middle of CB, okay? And from the middle of AC. The AC one would connect to what? B. So there's another median. And the CB one would connect to A. All right, this right here is called the centroid. Centroid. The point all right, so the place where all the medians intersect. The place where the medians intersect is called the centroid. And the centroid is the one that we're going to spend the most time on because there's something special about the centroid. And we're going to talk about that in just a second. So the centroid is the place where all the medians meet. And the medians, again, go from the midpoint to the opposite vertex. The midpoint to the opposite vertex. Okay, so to construct the centroid of a triangle, you do exactly what we just did. So you label the midpoints of the legs, you draw the medians of the triangle, and you label the intersection point, and that would be the centroid. So can I get somebody to come up here and try to construct this one? I need 3 people. Tiara, Gabriel, one more person. Daisy. Good. That works. All right, so our centroid would be where the green, the red, and the blue intersect. Now, recognizing that there's some allowance for human error here because we might not be able to perfectly identify where the midpoint is, but they should intersect. Since these don't intersect quite perfectly, I'm just going to make my centroid bigger. There it is. Okay, so there's the centroid of that triangle. Now, if you actually were to do that with a ruler and find the actual midpoint of each of these segments and draw it with perfectly straight lines, they would intersect and they would make a centroid. Okay, so that's the centroid of this triangle. This black dot is the centroid. All right, so I did it using lines just so you guys have another picture of it. Again, this is the centroid. This blue dot is the centroid. Now, there's a lot going on up here. I'm going to go back to the slide I just looked at, but just so you guys know, you'll have it here, so you don't necessarily need to copy it down, okay? So the centroid theorem says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. I think it's easier to just put numbers in to explain what that means. So the centroid of a triangle basically splits each of these lines into 2/3 and 1/3 segments. So that means if this is 3, this one is 6. If this were 2, this one would be 4. And if this were 1, this one would be 2. Okay? So the centroid splits all of the lines into 1/3 and 2/3 pieces. So for instance, let's call this one AB. AB total is how much? 3. So that means AC is 1 and BC is 2. All right? Because I just made those numbers up. So you add it together and say this is 1, this is 2, so the whole thing is 3. All right? What about DF? DF is how long? 9. Good. DF is 9. DF is 9. So then if this piece is 3, this one has to be 6. So if the whole thing is 9, you've got to split it into a 1/3, 2/3 ratio, which is convenient if they're divisible by 3. It's a little more difficult if they're not divisible by 3, but it will still work. Okay? All right, so then let's call this one. What are my, yes, what are my letters? A, B, C, D. I missed E, that's right. And G. All right, so EG is, Miguel, how long? 6. So then if EC is 2, CG would have to be 4. Okay? So when you're looking at this, I'm going to erase these numbers and just give you guys one and see if we can come up with it. So let's say that AB is 15. Let's say AB is 15. How could you figure out how long each of the other ones is? Charlize?
So A was...
Oh, C. Sorry, this should be C.
AC would be 5, and then CB would be 10.
Yeah, how'd you get that? I heard you, I know. All right.
So the half of it,
Half of what?
the
So the whole thing, but it's not half of it, right? Because half of it would be 7.5. So you had to figure out which one would be like, what could I add together where one was one part and the other doubled it to give you 15? Okay, so what if I told you that EG was 20? Then what would you do? Jennifer? Divide by 3. Why?
Because the things are in fractions of 3.
Uh-huh.
So if you divide by 3, that will give you one side.
Okay.
Then you just multiply times 2 for that to get the other side.
Okay, so let's go back to this AB one for a second. So basically, you know, looking at this, AC is the shorter one, right? Because AC is the one that goes from the side to the centroid. So AC is the shorter one. If I take 15 and divide it by 3, that gives me 5. And then I double that to get 10. That's really easy to do in your heads because 15 is divisible by 3. However, 20 isn't, but you still do the same process. So looking at this one, which one in EG, which one is my shorter side? EC is the shorter one because that one goes from the wall to the centroid, from the leg to the centroid. So I'm going to do 20 divided by 3, which is what? Should be 6.6 repeating. Yeah, 6.6 repeating. It's okay. Here, I'm going to round it. All right, 6.67. So that means that EC is how long? And then what would you do to find CG? Either subtract from 20 or multiply it by 2. Either one is fine. So I'm just going to subtract from 20 because it's simpler. All right, and I end up with 13.33. So that means this is 13.33. Okay. Questions on where those came from? So that's the centroid theorem. And again, the centroid theorem, these pictures I think are a little bit tougher to see. But again, if you let this be intuitive, which I think it will be for the most part, if you let it be intuitive, you will probably get these right. So if AM, in this picture right here, if AM is 3, what would MZ be? 6. Good. All right, which makes AZ what? 9. Good. Okay, try this one. If in ABC, AF is equal to 9 and GE is equal to 2.4, so find the length of AG and find the length of CE. So if AF is 9, then what would AG have to be? 6. Good. If GE is 2.4, so GE is this right here is 2.4, how would you find the length of CE? Multiply by 2 would give you what? 4.8. What's 4.8? CE? GC is 4.8, so then how would you find CE? Add them together, which would give you 7.2. Good. Okay, try these at your boards. All right, so when you guys are doing this, the one that I want to talk about, just to review, is number 4. If FR is 20.1, what is the measure of VR? So how do you find that? Somebody walk me through how you find FR. Tiara. Yeah, you're going to divide it by 3, and then VR ends up being which one, the shorter or the longer? So you get 6.7 and you're done there. What if I had asked you for VF? Multiply it by 2 or subtract it from 20.1. Whichever one is easier for you to do, it doesn't really matter, okay? How do you know which one's the shorter one? Yeah, it looks shorter, but remember, we don't want to assume in geometry, so how can you tell? It goes to the wall. Yeah, it goes to, or the leg. All right, the shorter one is going to go from the centroid to the leg. The longer one goes from the centroid to the vertex. Yeah. Okay, so if you're ever in doubt, because sometimes they'll look really similar on a picture. So if you're ever in doubt, the shorter one goes from the centroid out to the leg, and then the longer one goes from the centroid to the vertex. Okay. So the last thing we're going to talk about is an altitude of a triangle. So we've talked about 4 different things. We've talked about medians, we've talked about perpendicular bisectors and angle bisectors, and the 4th one that we're going to talk about is the altitude of a triangle. An altitude of a triangle is a perpendicular segment that goes from a vertex to the line containing the opposite side. So what that means is it goes straight from every vertex, and it's got to be perpendicular to the opposite side. So in this case, in this right triangle, that's really simple because I go straight from here to here, and that makes a right angle. So that's an altitude. The problem is sometimes in a triangle that's not a right triangle, it's a little bit harder to do that. So for instance, in this triangle right here, first of all, what kind of triangle is this? Obtuse. It's an obtuse triangle because this angle right here appears to be obtuse. All right, so it's an obtuse triangle. If I want to do an altitude from this vertex, if I draw a line right here, is that going to be perpendicular? Does that make a right angle? No. So what you have to do is extend the opposite side because otherwise this line will never make a right angle. So I'm going to move it around just for a second. So this red line is our altitude, and if I start it up here, I don't get a right angle until I get down here. So that means my altitude of the triangle is actually outside of the triangle. All right, so the altitude of the triangle is outside of it. You don't get a right angle until you're right there. So this red line is our altitude because it is perpendicular to the opposite side. However, it just happens to be outside of the triangle. Okay, so if I were going to do an altitude from this angle, or I'm sorry, from this vertex, where do you think it would be? Inside or outside the triangle? Probably outside of the triangle. Let's label our points. Let's say this vertex is A, this one is B, this one is C. The altitude needs to hit which side? BC, right? It has to hit BC because that's the opposite side. So if I take a line and draw it, all right, if I take a line and draw it from here, stop me when it looks like it's perpendicular. Okay, so that would be the altitude, which means what do I have to do with BC? Extend it, and I do that with a dotted line. Why do I do that with a dotted line? Why isn't it a solid line? It's not part of the triangle. So we do it with a dotted line because it's not necessarily an imaginary line. It's there, we can see it, but it's not part of the triangle. So this right here would be my altitude from A to BC. All right, if I wanted to do one from vertex B, I need to intersect which line?
The purple one.
Not the purple line. I want to go from B to get to AC, but it needs to be perpendicular. So is it perpendicular right here? No. So I'm going to go, tell me when you think it looks like it's perpendicular. Right here? Okay, so what do I need to do with AC then? Extend it just a little bit. And it makes a right angle right there. So here's the deal with altitudes. You're not going to have to construct them. You're not going to have to really do anything with them. You just need to know what they are. All right? And you need to be able to identify that when altitudes meet, it's called the orthocenter. All right? So this is our last vocab word of the day. It's called the orthocenter, the point of concurrency of the 3 altitudes. So these red points, or these red lines right here are all of our altitudes. This would be the orthocenter.
So we're never gonna have to
Nope, you're not going to have to construct them. I tried it last year, and it became one of those things that was like, you don't need it enough that it was worth the time it took to get there. So honestly, the only thing you need to know is that they meet at the orthocenter and what an altitude is. Gabe, did you have a question? No? Okay. All right, so this is the orthocenter, and it's the point where they all meet. So the orthocenter is where the altitudes meet. What is the point where the perpendicular bisectors meet? Circumcenter. What is the point where the altitudes meet? Incenter. And what is the point where the medians meet? Centroid. Those are the 4 things that you will need to know. So you'll need to be able to match up that vocab. And then the biggest thing you need to be able to do is work with the centroid theorem. So the 2/3, 1/3 thing. Okay? All right. So if BD is an altitude of ABC, what does that tell you? That this is a what kind of angle? 90 degrees. And that means this one's also what? 90 degrees. Okay, so those are 90-degree angles. It splits it into 2 triangles. BAD, angle BAD, where is that? Bottom left, right? And that's 5x minus 10. And ABD is 6x plus 12. Where's ABD? The top, the whole thing? No? What part of it? The left side? So 6x plus 12. And I want to solve for x. How could I do that?
5x minus 10 plus 6 plus 12 plus 90.
Okay, you could do that. Do you need this part? No? If I don't do this, what do I do with this? I could also just say this equals 90. Because remember, if one of them is 90, the other 2 have to add up to 90. They have to add up to 90. Okay, so then what's 5x plus 6x? 11x. What's negative 10 plus 12? Plus 2 equals 90. Now what? So 11x equals 88. And what's x then?
8.
Good. There you go. X equals 8. Okay. So just to review, what's a perpendicular bisector? It cuts the lines in half, so it goes from the midpoint to where? To the line. So it goes from the vertex right here, right? And it makes a 90-degree angle. Okay? All right. What about an angle bisector? Bisects the angles. So does it have to bisect the other side also? No, not necessarily. Okay. What's the point where they all meet?
The incenter.
This is called the incenter. All right. What about a median? The midpoint to the opposite side. Midpoint to the opposite side. And midpoint to the opposite side. And these all meet at the centroid. Centroid. All right, and then an altitude goes from a vertex and makes a right angle. All right, so an altitude goes from the vertex and makes a right angle. Okay. Questions on any of these? It's a lot of vocab, I know that. Okay. Go ahead and do your exit ticket on your exit ticket template from yesterday. If you did not get one, go grab one right now.